Hello, my name is Brandon Atkins, and this is a research presentation for Psychology 4017, Advanced Research Methods in Behavior Social Sciences. I conducted this research study on caffeine and its effects on sleep for my psychology class at Louisiana State University out of Alexandria. Now, I chose to conduct this research study on caffeine and its effects on sleep due to the growing popularity that we see of coffee consumption, specifically among college students. Now, one doesn't have to look far, especially on college campuses, to see the growing popularity of coffee shops, especially designer coffee, brand names, and even local coffee shops that students will frequent when they're doing homework or having social gatherings. With the increase in caffeine intake among college students, the side effects of the caffeine may disrupt the amount of sleep that students get each night. This is specifically important because sleep has a big influence on whether the students will be able to function and perform academically to the best of their ability. Now, there are side effects that come with coffee other than increased alertness, and that is also focus, attentiveness, and energy. Based on previous research, there are some previous studies that have been done on caffeine and its effects on sleep. According to Raj and Priya in 2018, caffeine can have negative side effects such as tension, cerebral pains, fretfulness, and sickness. Another study showed that caffeine consumption does result in going to bed later and spending less time in bed, therefore resulting in decreased quality amount of sleep. Now, looking at further research, we can kind of get a background on what previous research has shown us based on caffeine consumption and its side effects. According to Ferris et al. 2017, there's a significant relationship between caffeine consumption and sleep quality. Another study showed that as frequency of energy drink consumption increased, the experiences of anxiety and sleep disturbances increased as well. And that research study was done by Stasio et al. In 2011. So not only do we find caffeine in coffee, but energy drinks are another source of caffeine that are also popular with college students and the younger students and other populations as well. Then we have to focus our attention on caffeine tolerance, because this is another factor that could affect whether or not the side effects of caffeine will influence whether or not a student sleeps more or gets less sleep at night. So when we look at a study done by Rogers et al. In 2013, they found that caffeine tolerance has been shown to have an effect on the quality of sleep a student gets each night, as high caffeine tolerance can negate the side effects of caffeine. Another study by Vera et al. In 2019 states that the acute side effects of caffeine, such as alertness, health of the eyes, anxiety, and wakefulness, are subject to caffeine tolerance as well. So we can see how caffeine tolerance can play a factor in this. Now, looking at this current study, the research question in particular that I'm focused on is finding out if there's a correlation between the amount of caffeine a student consumes and the amount of sleep a student gets. Now, looking at this question, I have two hypotheses. The first research hypothesis states that students that consume more caffeine will get less sleep each night than students that consume less caffeine. Then factoring in the second hypothesis, we want to look at the effect of caffeine tolerance. So the second hypothesis states that students with higher caffeine tolerance will get more sleep than students with a lower caffeine tolerance. Now, to put this together and gather this information, the methodology that I used was a survey. So in particular in this study, those that responded were 36 college students attending LSUA above the age of 18. Now, participation was voluntary. A participant's gender, race, or any other demographical feature did not play a major role in picking the participants. The participants took a survey consisting of 15 questions, with some being multiple choice and some being fill in the blank. Before the participant could participate in the survey, there was informed consent that was provided before they moved on to the survey portion of it. And this informed consent ensured that the participants' information will remain anonymous and that they had the right to decline or withdraw from participation without any consequences at any time. So the participant could be in the middle of the survey and decide to change their mind, and they could exit out without any consequences at all. The questions on the survey refer to the participant's age, gender, their experience with coffee, caffeine tolerance, caffeine intake, sleep patterns, and sleep quality. This survey was created for the purposes of the study, so therefore no formal reliability or validity studies were conducted prior to that. The survey, however, does contain face validity. The limitations that could have an effect on the reliability and validity of the survey are the participants that are taking part in the survey don't answer the questions honestly. So if they just put in random selections on the survey or put in random information just to finish the survey, it could affect the reliability and validity of the survey itself. So with the procedure, the first variable in this research study I was looking at is caffeine intake, and that is defined as 8-ounce cup of coffee. So if the participant, for example, was to drink a 16-ounce or a grande, that would be considered 2 cups of coffee. The second variable is sleep, which is defined as the amount of hours a student spends between falling asleep and waking up in the morning. So in particular in the survey, I made sure to, when I asked the question about how much sleep the student gets, I made sure to ask the student to not factor in the amount of time they lay in bed before they actually fall asleep. So because some students will lay in bed, maybe be on a phone or watching TV, but not particularly trying to fall asleep at that particular moment. The third variable is caffeine tolerance, which is defined as the amount of caffeine that a student can consume without feeling any side effects such as an increase in energy. So there was a caffeine tolerance that was asked of the students. They had to rate it on a scale of 1 to 10, 1 not being tolerant and 10 complete tolerance. Age is an extraneous variable. Although age will not play a big factor in the results, it is asked on the survey. The survey was posted on SurveyMonkey, an external site, and was distributed to the students via the LSUA email server. As stated before, informed consent was obtained before the student began the survey, and participants could end the survey before completion without any consequences. A one-tailed Pearson's correlation was used to analyze the data since the research intends to measure the relationship between caffeine intake and the amount of sleep that the college students get each night. A one-tailed Pearson's correlation was also used to measure the link between caffeine tolerance and the amount of sleep that college students get each night. And after the data was analyzed, the p-value was calculated and is determined to accept or reject the null hypothesis. Now, gathering the data and analyzing it, these are the results. There were a total of 36 participants, with 35 being female and 1 being a male. Then, using Microsoft Excel, the correlation coefficient was conducted. The analysis using the Pearson's correlation coefficient was aimed to disprove the hypothesis: students that have a higher caffeine intake will sleep fewer hours than students with a lower caffeine intake. Looking at the results from this correlation, or the Pearson's correlation, and analyzing the data, I found no significance between the variables of coffee consumption and the number of hours a student slept each night. This shows, so the p-value, as you can see here on the screen, is 0.01 between the two conditions. P equals 0.912. So this shows a weak correlation between the variables of coffee consumption and the number of hours slept each night. So, to sum it up, these results indicated to reject the null hypothesis, as there was no significant relationship between the two variables. So, no relationship between coffee consumption, or the amount of coffee consumption, and the amount of sleep students got each night. that used the correlation coefficient aimed to disprove the other hypothesis that I had, which is students with a higher caffeine tolerance will get more sleep than students with a lower caffeine tolerance. The same 36 participants used the survey to self-report their level of caffeine tolerance based on a scale of 1 to 10, with 1 being no tolerance and 10 being completely tolerant. There was no significance found between these two variables as well. Caffeine tolerance and the number of hours slept each night. P, as you can see on the screen, equaled 0.01 between the two conditions. The final number that we have here at the bottom is P equals 0.482. Again, this shows a weak correlation between the variables of caffeine tolerance and the number of hours slept each night. And as like with the previous result, the results indicated to reject a null hypothesis, as there is no significant relationship between the two variables of caffeine tolerance and the amount of hours a student slept each night. This table right here is actually the participant characteristics. As you can see, we have the gender of every participant. As you can see, 35 are female, 1 is male. We have the age, all in chronological order, ranging from 18 to 47. Then we have the number of cups of coffee consumed that they reported. This is on a daily basis. The number of hours slept each night. And this is their self-reported caffeine tolerance right here on this scale of 1 to 10. This chart right here is for the first analysis that I conducted, Pearson's correlation coefficient on caffeine consumption and sleep. As you again can see, we have the genders here on the left side, their ages, the number of cups of coffee consumed, the number of hours slept each night, and then all these numbers here were analyzed, computed, and we got a sum here at the bottom. So the average, as you can see, of cups of coffee consumed is 2.5. The average number of hours of sleep among all participants is 7. We have the sums here of the data analysis, and this is how, putting all this information together, these 4 columns, or I should say 5 columns here, and then averaging out these sums at the bottom, this is how I got the p-value for this one. Again, this table, similar to the last one, is the Pearson's correlation coefficient of caffeine tolerance and sleep. As you can tell, as just similar to the previous table that I showed you, we have their age, their gender. This one has caffeine tolerance instead of the number of cups of coffee consumed, the number of hours of sleep. And with the same analysis I did with the previous table, that's how we got the p-value, which determined if there was a relationship between the variables or not. So, based off these results, the current study revealed no significance between the amount of coffee consumed and the amount of sleep that students got each night, therefore rejecting the first hypothesis and the second hypothesis as well. These results actually contradict the results of a previous study done by Heidmach et al. In 2000, which showed that caffeine consumption has a significant impact on the sleep quality and sleep quantity of the participants. These results also contradict the research results of Untitled et al. 2015, which showed a significant relationship between caffeine intake and sleep duration in adolescent participants. The results of this study show that caffeine consumption has little to no effect on the amount of sleep students get each night, based off this current study. Despite these results, there are a few limitations with the current study to consider. There was a disproportion of male and female participants, so 35 females and only 1 male. The confounding variable, the time of the day that coffee is consumed, could have affected the results as well. The majority of the participants, 53%, reported drinking coffee only in the morning, while another 6% drank coffee around noon. Only 8 of the participants reported drinking coffee throughout the day. This could support the research by Rogers et al. In 2013, where the researchers indicated that the time of day that caffeine is consumed may determine its effects on sleep. This could also indicate that there is no correlation between the variables, since coffee consumption occurred early in the day, which means that the side effects of caffeine would not have an influence on sleep at night for the students. Caffeine tolerance also would not be a factor on sleep duration, since the side effects of caffeine would have most likely worn off by the time the student goes to sleep. So, based off this information, looking at the conclusion and directions for future research, this research study did not consider the time of day that students consume coffee and how it would impact the results. Based off the limitations of this current study, future studies should consider the confounding variable, the time of day that the coffee is consumed, to see if it has an effect on sleep. One suggestion is for future study to determine if students that consume coffee in the evening sleep less than students that consume coffee early in the day, such as the morning. The results of this study could have also been used to set the basis for future research studies to discover what the optimal times are for college students or another population to drink coffee so the effects of caffeine are minimized. This could provide insight into the lasting effects of caffeine and how it influences sleep quality and duration. And here are the references that I used for this study, previous research, and relating to other information that I used to put the survey together. Thank you so much for viewing this presentation, and have a great day.